Welcome to Let Me Fix This. Enjoy the video.
In this video, I will explain how to get to Gemini Exoplanet Solutions, updated. Begin by clearly defining mission objectives and selecting target coordinates, then quantify payload mass and delta-v limits. Prioritize instruments and observation wavelengths that match science goals. Estimate travel time and identify propulsion trade-offs like chemical versus electric systems. Use incremental milestones for design reviews and simulations, and prepare contingency plans for communications and navigation challenges during cruise and encounter phases. Plan efficient trajectories using gravity assists and resonant flybys where feasible to lower delta-v and shorten travel time. Model transfer and launch windows with high-fidelity orbital tools to identify optimal departure opportunities. Integrate robust navigation solutions like star trackers, pulsar timing, and autonomous orbit determination to handle long cruise phases. Test guidance algorithms in simulation and hardware in the loop, and verify margin for course corrections and unforeseen maneuvers before committing to final trajectory plans. If you're finding this video helpful, please subscribe and like to support more guides and updates. Quick recommendation: make meal prep easy with leak-proof containers that seal tightly and prevent spills during long project sessions or travel planning. I find these containers save time and reduce mess when I'm deep in simulation work or packing for field tests. Check the description for the link and other deals, and now let's get back to the video. Select propulsion by weighing thrust, specific impulse, and operational complexity for your mission profile. Size power systems to reliably support instruments, communications, and periodic course correction burns, and consider solar versus reactor choices based on distance and power needs. Build redundancy into critical subsystems like communications, guidance, and thermal control to reduce single-point failures. Validate component lifetimes under expected radiation and thermal cycles, and ensure maintainable software architectures that support autonomous operations far from Earth.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.